This is a lesson on structure, acid-base properties, oxide, acid-base properties, and Lewis. So it's sort of a catch-all of things. If you have a binary acid, HX, the strength of that acid depends upon how strong that acid is, depends upon the strength of the bond, and polarity. If the bond is not polar, then it will not lose hydrogen. So it has to be polar, but the strength of the bond has to be weak enough so that the hydrogen can leave. Hydrogen fluoride is much more polar, hydrofluoric acid is much more polar than hydrochloric acid. Hydrochloric acid is a very strong acid. Hydrofluoric acid is a weak acid. Even though this is much more polar, it's counteracted by being very strong. HBr, hydrobromic acid, is less polar, but it is also a weaker bond. So as you go down a group, the strength of the bond gets weaker, but it's also less polar. So hydrochloric acid has the best of the two. It's polar enough and weak enough. So that's if it's a binary acid. If it's an oxy acid, meaning it has oxygen on it, where X is the anion, it depends upon the electronegativity of X of X, the element, and the number of oxygens attached to X. If you have HOCl versus HOI, Cl is a more electronegative than I is, so this would be a stronger acid. This would be a weaker acid. The other variant is how many oxygens are attached to the Cl, not the H. What we have here is this situation with HOCl, and if you have the opposite, a related acid, oxygen is really electronegative, and what it will do is it'll suck up a lot of electron clouds to it. So the more electron clouds there is, the weaker this bond is, and it's easier to form an H+. Here, there are no other oxygens out here in this region to suck away the electron cloud, so the electron cloud is centered more on the oxygen, and therefore this bond between the O and the H is stronger. Acid-base properties of oxides. If you have a non-methyl oxide plus water, you'll form an acid. For instance, SO3 plus H2O yields H2SO4. Sulfuric acid is an acid. In fact, this is what happens when you burn coal with a high sulfur content. You'll form sulfur trioxide. It'll go up into the atmosphere, mix with water, the clouds, and fall as acid rain. So, if you have a non-metal oxide, sulfur, nitrogen, phosphorus, any other non-metal oxides that you have, combined with water, then it'll form an acid. Metal oxides, on the other hand, plus water will form a base. In this case, say NaO plus, not NaO, that's the wrong formula. Let's say calcium hydroxide, or calcium oxide, plus H2O will form calcium hydroxide. This is lime, and sometimes in your yards, if your soil is too acidic, especially around pine trees, you will put some lime on your ground and it'll produce some base, and it'll counteract the acid in the soil, like with clays. The last thing we got is Lewis acids and bases, and this is the last of the definitions of acids and bases. Lewis acids and bases are prevalent in organic chemistry. So a Lewis acid is an electron pair acceptor, while a Lewis base is an electron pair donor. The acid is the Bronson-Lowry definition of an acid is a proton donor, which means it's losing a plus. The electron pair acceptor means it's gaining a negative, so it's same deal. It's going to become more negative. Same thing with a base. A base is a proton acceptor, is an electron pair donor, which means in both cases it's becoming more positive in the end. We use this in organic chemistry because of the nitrogen being involved a lot. If you have BH3, which is a very common Lewis acid, Lewis base, Lewis acid, plus ammonia, and you can always tell the base because it has a lone pair on it. So what happens is you form a joint, a bond between these two, and you get HB bond NH. So this is the bond. Where's this bond coming from? Well, the electron pair is being donated by the Lewis base. Lewis base electron pair donor. It's the one with a lone pair on it. And it is going to the substance that does not have a Lewis, not have a lone pair. Small, positively charged ions will do stuff, and they will do with ammonia or water, sometimes with hydroxides or oxides. Hydroxides. So they will join with this, and they'll form ligands like that. We'll talk more about that in the future. A summary of all the types of acids and bases we have. Arrhenius will have one product going to do one reactant going to form two products, like LiOH forming Li plus OH minus. Bronsted-Lowry, which will have two reactants, two products, and this is a general case. Sometimes you can get them to do different things. HCl plus H2O, H3O plus Cl minus. And then the Lewis, which will have two reactants, making one product. BH3 plus NH3 makes H3B and H3. That concludes this lesson on a catch-all of strengths of acids, oxides, and Lewis acids and bases.